Section 9.2 is series and convergence. In this section, what we're going to do is define what an infinite series is, and then determine different ways that we can find out if a series converges or diverges. Let's begin by defining an infinite series. Now remember, what we said in section 9.1 is that this is an infinite sequence, so it's a list of numbers. Well, if we take that list of numbers and we sum it from n equal 1 to infinity, we get what's known as an infinite series, which is just an infinite sum. So an infinite sum is just an infinite series. It is taking some formula and adding all the terms together infinitely. We're going to spend the next few sections learning different techniques that are going to help us determine whether a series diverges or converges. Let's talk about the convergence and divergence of a series. Now for an infinite series, the sum from n equal 1 to infinity of a sub n, the nth partial sum is equal to a sub 1 plus a sub 2 plus a sub 3 plus all the way to a sub n. That's just an nth partial sum. What we say is that if we can find the formula, that sequence s sub n, which would be just a way that we could list out the partial sums, if we can find this formula, then we can treat it as a sequence. Well, how do I know if the sequence converges? Well, the limit as n goes to infinity of that sequence would have to equal a number. If that sequence converges, then your series converges, and the limit is the sum, and we usually call that s. So instead of L here, you can think of that as s. And if the limit as n goes to infinity of s sub n, if that limit does not exist, if that sequence diverges, then your series diverges. So the sequence of partial sums can tell us whether a series converges or diverges. Again, we know how to determine if a sequence converges or diverges. We just take the limit as n goes to infinity of that sequence. So if we can find that sequence of partial sums, then we can determine if we diverge or converge. Let's just practice finding sequences of partial sums so we understand what they mean. And then we're going to look at how to find the sequence of partial sums for telescoping series. We want to find the sequence of partial sums s sub 1, s sub 2, s sub 3, s sub 4, and s sub 5. Well, s sub 1 just wants you to add the first term. Well, the first term is just 1, so s sub 1 is just equal to 1. S sub 2 wants you to add the first two terms together. So 1 plus a half, if we were to add those together, we end up with 3 halves. S sub 3 would be the first three terms, 1 plus a half plus a fourth, and we end up with 7/4. S sub 4 would be 1 plus a half plus a fourth plus an eighth, and we'd end up with 15/8. Finally, S sub 5 would be 1 plus a half plus a fourth plus an eighth plus 1/16, and there we would get 31/16. So a partial sum is just looking at a certain number of terms added together. Now if we wanted to list out our sequence of partial sums, our sequence s sub n would be 1, 3 halves, 7/4, 15/8, 31/16, all the way down to the nth partial sum. In order to determine if this infinite series converges or diverges, we would have to find the formula that would give us a 1 when we plugged in 1, would give us 3 halves when we plugged in 2, would give us 7/4 when we plugged in 3, would give us 15/8 when we plugged in 4, and would give us 31/16 when we plugged in 5. And finding that formula, this is difficult. So we're only going to do that when we have a telescoping series, which we will explore a little more on the next page. What we're going to talk about right now is something called a geometric series. A geometric series is a series in the form a plus a times r plus a times r cubed plus ... plus a times r to the n. So it's an infinite series where you have a times the power of r added together infinitely. as a summation formula, we'd say it's the sum from n equals 0 to infinity of a times r to the n. So this is a geometric series. Now for the geometric series, we say that a is always equal to the first term. It's what you get when you plug in the counter wherever you start. A never equals 0, and r is called the common ratio. Now we can determine if a geometric series converges or diverges by looking at that common ratio. We can determine the convergence or divergence of a geometric series by looking at the common ratio r. If the absolute value of that common ratio is greater than or equal to 1, the series diverges. If the absolute value of that ratio is less than 1, your series converges, and we can actually find its sum. The sum of that series is going to equal a over 1 minus r, where a again is that first term. And then r is always going to be that common ratio. So was example 1, the one that we were looking at earlier, was that geometric? This is that series. Is this something that's geometric? Well, let's figure out if we have a common ratio that gets us from the first term to the next term, and then to the next term, and then to the next term, etc. So here I multiply by r, multiply by r, multiply by r, so we're multiplying by that common ratio. Yes, example 1 is geometric because to get from 1 to a half, I multiply by a half. To get from a half to 1/4, again I multiply by a half. From a fourth to an eighth, I multiply by a half. From 1/8 to 1/16, I multiply by 1/2. What does that mean here? That means that r is equal to 1/2. So was example 1 geometric? Yes. Does it converge or diverge? Well, if it's something that's geometric, we know it's going to diverge if the absolute value of r is greater than or equal to 1, and that it's going to converge if the absolute value of r is less than 1. Well, if this is r, the absolute value of r would still be a half. Well, a half is a number that is less than 1, therefore this series is going to converge. Since it's converging, we can actually find its sum. The sum of this series, and we're going to call it s, is going to equal a. Well, a is always the first term. Well, my first term was 1 divided by 1 minus r. Well, that r, that common ratio, is a half. And 1 divided by 1 minus a half is going to be 1 divided by a half, or 2. Which means that this infinite sum, when you're adding all the terms together, is approaching 2. Now let's learn about telescoping series. For a telescoping series, we're going to be finding this formula for that partial sum. Because remember, I said that's actually pretty hard. Finding the formula for this partial sum takes a lot of thought, and for other series, it's almost impossible to do. So the one that is easy to do is the telescoping series. So a telescoping series is basically a series where many of the terms in the series will cancel each other out. Because a lot of the terms cancel each other out, it makes it easy to find that formula for the partial sum. Once we know this formula, once we know what this guy is, this s sub n, this formula, then what we can do is determine if the series converges or diverges by taking the limit as n goes to infinity of s sub n, because this now is a sequence. And we know that if we take the limit as n goes to infinity of the sequence and we end up with a number, our sequence converged. If the sequence converges, so does the series. If we took the limit as n goes to infinity and our sequence diverged, then our series will also diverge. Now let's do number 2, where we determine if the series converges or diverges. If it converges, we want to find the sum. This is definitely not geometric when I look at it, because geometric series, remember, are the ones that are going to be the sum from n equals 0 to infinity of a times r to the n. So they're always going to have some number raised to the nth power, and this does not have anything raised to the nth power. But it does have a minus sign, and since it has a minus sign, it makes me think that it's telescoping, because I know that a telescoping series has a lot of terms that will cancel each other out. How do they cancel each other out? They usually have that minus sign. So what we need to do is find the formula for the partial sum. How do we do that? We just start listing out the terms to find S sub n. S sub n would equal, the first thing I'd add is the first term. When n is equal to 1, it's going to be 1 over 1 minus 1 over, and then 1 plus 1 is 2. And then plus, when n is equal to 2, it would be 1 over 2 minus 1 over 3. All we're doing is plugging in these numbers in place of the n's in our formula. Now when n is equal to 3, I'd have 1 over 3 minus 1 over 3 plus 1, which is 4, plus dot 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 plus. Now let's do when n is equal to n minus 1. When n is equal to n minus 1, I would have 1 over n minus 1 minus 1 over, if I plug in an n minus 1 here, that becomes n minus 1 plus 1, which just cleans up to n, plus, now the nth term, when n is equal to n, and I would have 1 over n minus 1 over n plus 1. Now let's see what, if anything, cancels. Well, I notice that I have a negative 1/2 and a positive 1/2. Those will cancel. Same thing here with the negative 1/3 and the positive 1/3. Those will cancel. Well, if I were to have written the next term here, n equal 4, I know this negative 1/4 would have canceled, so I know that that also goes away. On the other side, I notice that I have a negative 1 over n and a positive 1 over n, so I know that those will cancel. Well, if I would have written here the term before n equal n minus 2, then this term would have canceled as well. So it looks like the only things that I'm left with is my very first term and my very last term. S sub n, the partial sum, is 1 over 1, or just 1, minus 1 over n plus 1. So this guy here is this formula to find the sum of the first m terms. So since this is a sequence, we can determine if this sequence converges or diverges. How do we do that? We take the limit as n goes to infinity of that sequence. So the limit as n goes to infinity of 1 minus 1 over n plus 1 is going to equal 1 minus, well, that's going to be 0, and that's going to be 1. Since this was a number, that meant that the sequence converges. Well, since the sequence converges, therefore the series also converges. And then the sum here is equal to the limit, which is 1.